So this passage is conflicts. It's the hypothesis of the scientific process. And there's not a real shortcut to it. You're going to take something that you may not understand and try to figure it out, like understanding the rules of an unusual sport that you don't know. So in our DRC approach, there's only one conflicts passage per test. You're going to carefully read, helps you remind you of that, the C and the C conflict, C, carefully read. You're going to have the first step is to identify the conflict, and the second step is to identify the different approaches to the conflict and then answer the questions.
Step 1 is to determine the conflict. In the fall, monarch butterflies in eastern North America migrate to Mexico, where they overwinter in high altitude forests. The butterflies store body lipids. They use it as a source of energy, so they eat. Consider the following 3 hypotheses pertaining to when the butterflies store lipids and when the energy for stored lipids is used with respect to migration and overwintering. So the conflict is that stored lipids, when do they use them with respect to overwintering? So when do butterflies eat and use their food as they prepare to travel to Mexico? That's the conflict. So step 2 is to determine the differences. In hypothesis 1, monarch butterflies require energy for stored lipids for migration and during overwintering. The butterflies store lipids before they begin their migration. During migration, as stored lipids are converted to energy, lipid mass continuously decreases. When the butterflies reach the overwintering sites, ending the migration, they must store lipids again before beginning the overwintering period. So they eat before they leave, they get thin as they travel, and they eat again when they get to Mexico for overwintering. Okay. Hypothesis 2, monarch butterflies require energy for stored lipids for migration. The butterflies store lipids before they begin, so that's similar to hypothesis 1. During migration, the mass continuously decreases, also similar to hypothesis 1. Because the energy for stored lipids is not required during overwintering, they do not store lipids while at the overwintering site. So they eat before they leave, they get thin as they travel, and they do not eat when they get to Mexico. Right? They get there and they go, oh man, I'm tired, and they just relax. And then hypothesis 3, monarch butterflies require energy for stored lipids during overwintering but not migration. The butterflies do not store lipids before they begin. Instead, they're stored during migration and their mass increases. Okay, so they don't eat before they leave like 1 and 2. They eat as they go. They're stopping and getting some fast food on the way. And they get fatter as they go. The butterflies arrive at the overwintering site with enough lipids to provide themselves with energy, so they do not store lipids while at the overwintering site. They don't eat before they go. They eat as they go and get fatter, and they don't eat in Mexico. Which hypotheses, if any, asserts that monarch butterflies stored lipids during 2 distinct periods? So we look back and we say in hypothesis 1, they eat before they leave and they eat when they get to Mexico. So it has to be hypothesis 1. Which hypothesis, if any, asserts that monarch butterflies require energy from stored lipids neither for migration nor during the overwintering period? So which one says they don't need any food at all? And none of them do. These eat before they leave, these eat before they leave, these eat as they go. So they all say they need food in some way, so none of the hypotheses say that. Based on hypothesis 3, which of the following figures best depicts the change in lipid mass of a monarch butterfly from the beginning of migration to the end? Okay, so hypothesis 3, they eat as they go and they get fatter. They don't eat before they go. So which one says they get fatter as they go? That's choice J. As time increases, their mass increases. Number 11, assume that changes in body mass of a butterfly are caused only by changes in the mass of stored lipids. The statement, the percent of monarch's butterfly's body mass that is made up of lipids is greater at the beginning than at the end of migration, is supported by which hypothesis? So which butterflies lose mass as they go? So if we go back to our ideas, the ones that our annotations, the ones that lose mass are hypothesis 1 and hypothesis 2. So our answer has to be 1 and 2 only, so C. To store lipids, monarch butterflies convert sugar from nectar they have consumed into lipids. A supporter of which hypotheses, if any, would be likely to claim that to ensure the butterfly can store lipids for overwintering, nectar must be present at the butterfly's overwintering site. So which ones eat when they get there? Right? The one that eats when they get there is hypothesis 1. All the others do not eat. So has to be hypothesis 1. Which of the following statements about lipids in monarch butterflies is consistent with all 3 hypotheses? The butterfly's mass does not change during the overwintering period. Well, that's not true because butterfly 3 gets fatter. The butterfly's lipid mass changes during migration. That's true. Butterflies 1 and 2 lose mass, and butterfly 3 gains mass, so B. When monarch butterflies use their stored lipids, the lipids must be broken down to produce energy-rich molecules that can be readily used by cells. Which of the following molecules is produced as a direct result of the breakdown of lipids? This is a science knowledge question that you either know or you don't know, and so the answer is ATP. You're going to have somewhere between 2 and 4 questions either about science knowledge or science process on the test.